MAXVY.
Welcome to part 2 of MAXVY's Verilog tutorial series. In this video, we will introduce you to the hierarchical modeling concepts. In this video, we will explore key design methodologies including both top-down and bottom-up approaches. There are two basic types of digital design methodologies, a top-down design methodology and a bottom-up design methodology. In a top-down design methodology, we define the top-level block and identify the sub-blocks necessary to build the top-level block. We further subdivide the sub-blocks until we come into leaf cells, which are the cells that cannot further be divided. In a bottom-up design methodology, we first identify the building blocks that are available to us. We build weaker cells using these building blocks. These cells are then used for higher level blocks until we build the top level block in the design. 4-bit ripple carry counter. A ripple carry counter, also known as a ripple counter or asynchronous counter, is a type of digital counter where the output of one flip-flop is used as the clock input for the next flip-flop in the chain. It consists of a series of flip-flops connected in sequence. Each flip-flop represents a single bit in the counter, and the entire sequence can count up to 2 power n minus 1, where n is the number of flip-flops. The first flip-flop toggles its states on each clock pulse. Each subsequent flip-flop toggles when the previous one transitions from high to low. Implementation of T flip-flop. Data flip-flop has two main inputs, data D and clock C, and it also has two outputs, Q and Q complement. Here we only consider the output Q. The D flip-flop latches the input value D to the output Q on the falling edge of the clock signal. The value of Q only changes at the clock edge and follows the value of D. An inverter is a simple digital logic gate that outputs the opposite of its input. If the input is 1 and the output is 0, and vice versa. Here, the input of the inverter is connected to Q and the output of the inverter is connected to the D input of the flip-flop. When Q equal to 0, the inverter feeds 1 into the input of the D flip-flop. On the next falling edge of the clock, the D flip-flop captures the value 1 from the D input and sets Q to 1. A D flip-flop with the addition of a feedback inverter can effectively function as D flip-flop, toggling its output state on each clock pulse. Design hierarchy of ripple carry counter. In a top-down design methodology, we first have to specify the functionality of the ripple carry counter, which is the top-level block. Then we implement the counter with toggle flip-flops. We build the toggle flip-flops from the D flip-flop and an additional inverter gate. Thus, we break bigger blocks into smaller building sub-blocks until we decide that we cannot break up the blocks any further. A bottom-up design methodology flows in the opposite direction. We combine small building blocks and build bigger blocks. Have any questions or doubts? Free feel to write your comments and doubts in the comment section. Thank you. See you in the next video.